Hello students, welcome to your pre-calc review video. In this video we are going to go back and briefly look at all of the topics and chapters that we've covered in pre-calc, just to hopefully refresh your memory on some things and give you sort of an idea of what may be fair game for our final quiz that we're going to take tomorrow. Just as a reminder, that final quiz is only going to count if it improves your grade. You have to take the quiz, but if you take the quiz and don't just skip it altogether, I will excuse you from that grade being calculated if it doesn't improve your overall grade currently. So like I said, we're just going to briefly go through some things in this video, which hopefully sparks some of your memory, and you can ask questions if you need to about things that you forgot or things that you don't think you ever learned in the first place. So we started out with chapter 1. The first section of it was about parent functions and transformations. This was really a review of Algebra 2, where we talked, we should have somewhere at the beginning of our notebook some parent functions. Whoops, let me try that again. So parent functions like y equals x squared, we should know what that graph looks like. Y equals x to the third, we should know y equals the absolute value of x is a letter v. Y equals the square root of x, starts here and does that thing. Y equals 1 over x we talked about more later. That was like the whoop and the whoop kind of graphs. I'm trying to think what else we had in there. What other parent functions do we have? Y equals, maybe 2 to the x, right? An exponential growth function. Or y equals, those are the 6 we had. So there you go. There's the 6 parent functions that we should know the graph of. And then transformations obviously is what happens when we, plus 3 at the end of an equation, or what happens if we minus 2 just to the x on an equation, what happens when we multiply, and so on. So stretches and shifts, flipping it over by putting a negative in front, and so on, okay? So parent functions and transformations was, like I said, the first thing that we covered way back in chapter 1. The other thing that we covered in chapter 1 that was important for the rest of our course was the idea of radians as a way to measure angles. So radians, remember, are in terms of pi. So, radians are defined as, the angle or the piece of a circle that's cut off by an arc that's the same length as the radius. That was the origin of that. 1 time around a whole circle is 2 pi radians. And so then we had all these other angles in the unit circle based on radians. Okay, so we talked about converting radians to degrees. Right, if we know that it's, let's say, pi over 4 radians, we want to multiply by 180 over pi to cancel out the pi to get degrees. 180 divided by 4 would be 45 degrees, right? And then going the other way, if we had 45 degrees, we want to multiply by pi over 180, right? And so then we get 45 pi over 180, and we can simplify that. So converting from radians to degrees and degrees to radians was one of the main things that we talked about. And then the other major application, of course, is our unit circle. So chapter 1 is where we first were introduced to the unit circle and the idea that, this is pi over 4, and this is pi over 3, and this is pi over 6, and pi over 2, pi, 3 pi over 2, and all these different angles measured in radians in the unit circle, right? And remember, the unit circle is just a circle with a radius of 1, which obviously comes back later on. But after we talked about radians in that way, we transitioned to talking about area under a curve. We wrote a program for this area curve. This is also where we were talking about rectangles, right? Left endpoint rectangles, right endpoint rectangles, trapezoids, midpoint rectangles very briefly, but not a ton. And this was also the chapter with a lot of summation notation, okay? A lot of summation notation. So we talked about, starting k equals 0 and going up to 4, right? So this would be 5 rectangles, and we talked about, putting some formula in here and multiplying by, whatever the width was of our rectangles. So we had summation notation, but then we wrote programs that included that summation notation and dealt with it. So we don't really have to do much of this by hand anymore. Because remember, we do have a sum program in our calculators, hopefully. If we want to add together all the square numbers, right? We just put x squared into our y1, and then we can run the sum program from 1 up to 5, right? That would add 1 plus 4 plus 9 plus 16 plus 25. So we had ways to deal with summations, but this is our notation. Remember, index on the bottom, index on the top, and whatever it is that you're trying to sum up next to that. Okay, so area under the curve, again, was a major part of chapter 2. That was the main thing we were doing in chapter 2, was finding area under a curve. So you can go back and look at that. Obviously, chapter 2 in your first volume of your textbook. Chapter 3 was about exponential functions and logarithms. Okay, so we talked about exponentials and logarithms, where we were sort of investigating exponentials that look like this. Y equals a times b to the x. We talked about how we can take coordinate points, something like this, and how we can write an exponential function that goes between this point and this point, right, by just plugging x and y in and solving. So we would plug 3 equals a times b, and 27 equals a times b to the 4th power. So then we would actually flip those around, and then we would divide them. So we just divide the whole thing. 27 divided by 3 is 9. The a's cancel out, and this is b to the 3rd. We would cube root both sides, cube root the 9. That's going to be some crazy decimal, but that's what b would equal. And then we plug it back in probably to this one, and then we solve for a, right? So we talked about that, and then we spent the rest of chapter 3 talking about logarithms. Logarithms, again, remember, are the inverses of exponential functions. So they are the opposites. They undo exponential functions. So logs, we talked about their laws some, right? We talked about if I have the log of a plus b, nope, just kidding. The log of a times b, right, is equal to the log of a plus the log of b, so on. We have all of those rules and formulas and laws back in section 3.3, so page 159-ish of volume 1 of your textbook. But we also used logs, remember, to solve exponential equations when we had, let's say 17 is equal to 3 times 4 to the x plus 1. And we divide by 3 and divide by 3, and so 4 to the x plus 1 is equal to 17 over 3, which would be 5.6 repeating, right? And then if we log both sides, or natural log both sides, right, we can take this x plus 1 and bring it to the front. Remember, that was the power rule of logs. So x plus 1 being multiplied by the log of 4 is equal then to the log of 5.66, and we could continue by dividing away the log of 4, subtracting 1, and we would find our answer. We also, in that same section, talked about change of base formula, right? Because our calculator can only do log base 10 or log base letter E, remember, or number E by doing natural log, but we can change the base. So look back at the change of base formula there as well, right? So that's chapter 3. Particularly the end of chapter 3 is what we're worried about, sections 3.2 and 3.3 specifically. After we talked about that, we went back into chapter 4 and back into the unit circle and started talking about the unit circle in terms of trigonometry. Okay, we talked about sine and cosine in the unit circle, right? Remember that the sine is the y values and the cosine is the x values, right? How far away from the origin are we? Tells us the sine and cosine values of specific angles in the unit circle. right? So we labeled these with coordinate points. This one would be 1/2 for x or for cosine, radical 3/2 for the sine or for the y coordinate, right? So we did a lot of that. We talked about graphing sine and cosine. We went from the unit circle to then looking at sine and cosine on a graph. So periodic functions, you know, like this. We did a lot of graphs with the period, with the amplitude, vertical shifts, and things like that, right? So if we have something like this, 2 sine x minus pi over 4 plus 1, we should be able to find a lot of information about that graph. The period is 2 pi. The amplitude is 2. It's been shifted to the right by pi over 4 and up by 1, and so on. So we can graph equations. We can write equations maybe from a graph, right? We also looked at our first trig identities. So we talked in this chapter about sine squared plus cosine squared is equal to 1, as long as, you know, they have the same thing in the parentheses. Sine squared x, cosine squared x is equal to 1 all the time. And we talked about other types of identities as well. This is also where we introduced cosecant and secant and cotangent as the reciprocal trig functions, right? Cosecant 1 over sine, secant 1 over cosine, cotangent 1 over tangent, right? So that was chapter 4, talking about sine and cosine in the unit circle, looking at some graphs of sine and cosine, identities of sine and cosine, and those extra trig functions. Once we dealt with all that stuff, we moved on to chapter 5. Oh, well, there's graphing sine and cosine, which, like I said, we already talked about that. And trig equations and formulas. Okay, so let's see. Trig equations and formulas is more like chapter 6, right? So chapter 6, we talked about trig equations and formulas. This was where we started solving things like sine x is equal to 1, right? We got values of x from the unit circle for these types of things. We also solved, you know, sine of x is equal to 0.3 by doing sine inverse. And remember, sine inverse allows us to flip the x and the number. So 0.3 sine inverse is equal to x, right? We talked about plus 2 pi n in terms of solving these things if we are allowed to go around and around and around and around again. This was also the chapter in chapter 6 where we talked about sine inverse and cosine inverse in terms of their graphs, and also tangent inverse. Remember that we cut off the graphs so that they don't extend vertically forever and break the vertical line test all the time. So look back at the graphs of sine and cosine inverse in those videos from section 612. And then we talked in the rest of chapter 6 about different formulas. We talked about double angle formulas. Actually, before that, we talked about angle sum and angle difference formulas, right? Cosine of a plus b, sine of a plus b, cosine of a minus b, and so on. Sum and difference formulas, those led us into the double angle formulas. And then the double angle formulas, we also talked about the half angle formulas. And actually, one of the double angle formulas led us to the half angle formulas. So those types of formulas dealing with sine and cosine are in chapter 6. We should be able to use them to simplify expressions. We hopefully can use them to solve equations, right? That was the more complex trig equations, section 632. So yeah, we did not do section 6.4, and we only did one part of section 6.2. So the things that we did not do in chapter 6, 6.13, we did not do. 6.21, we did not do. 6.23, we did not do. And then none of 6.4. So 6.41 and 6.42, we didn't do those either. Okay, so we did not touch that. Okay, so that's all of our trig stuff, right? Graphing sine and cosine, unit circle, trigonometry, the other trig functions, trigonometric identities, and then all this trig equations and formula stuff from chapter 6. So chapters 5 and 8, then we dealt with limits. So this limits was chapters 5 and 8. And in chapter 8, really all we did was the race to infinity. Okay, the race to infinity and beyond, right? No, Toy Story. Okay, race to infinity and rational functions, right? We looked at then limits of, 2x squared plus 3 over 4x minus 1, right? So we talked about dominant terms in the race to infinity and what that does to limits as x approaches infinity or possibly negative infinity. In chapter 5, we dealt a lot more with limits of functions at specific x values, right? So we talked about one-sided limits. We talked about two-sided limits. And remember, two-sided limits are the ones that we decided may not exist, right? Two-sided limits do not exist if the two sides don't agree. We put the bugs on the functions and walk them towards each other. We talked about one-sided limits, particularly in points of discontinuity, right? Where at a certain x value, we maybe had going up and going down. So we talked about this as a point of discontinuity. And from one side, it's infinity, and from the other side, it's negative infinity. We did a lot with piecewise functions as well, not only in chapter 5 with limits, but also earlier in the course, we talked about piecewise functions. Remember, those, where f of x is equal to something here, 2x minus 1 and 3x squared, right? When x is less than or equal to 2, x is greater than or equal, or not greater than or equal to, just greater than 2. So we could check and see, right, if this function is continuous. We talked about, a more formal definition of continuity when we dealt with limits, 3 things that were necessary, right? The point has to exist, the two-sided limit has to exist, and the point and the two-sided limit have to agree with each other. So that was also chapter 5, I think. Pretty sure it was chapter 5. I can't see it necessarily in these titles of the sections, but chapter 5 material and also chapter 6 material are all obviously on Google Classroom, as well as chapters 7 and 8. So limits, one-sided, two-sided, going to infinity, going to a specific point, one-sided, two-sided, and so on. So that was sort of our introduction to limits, and this is a key concept when we get to calculus. Okay, calculus is going to start with a discussion of limits, then talk about discussion of area under the curve. Remember integrals and things like that. We talked about that symbol. So then the last thing that we did, or the only other thing that we did in chapter 7, we did 2 sections of chapter 7. We did section 7.1.1 and 7.1.2. So we combined them into one. Section 7.1 was about describing functions. So we talked about increasing, decreasing. We talked about concavity, right? That was some of our new vocabulary. We talked about concave up, concave down, up versus down. And then in section 7.1.2, we talked about even and odd functions. Remember that most functions are not even or odd, but they're neither. But sometimes functions have properties that make them even or odd, right? About symmetry of the graphs, what happens when we make the same value positive and negative, okay? So that stuff also is in Google Classroom. Section 7.1, we did it just a couple weeks ago or a week ago, describing functions in these 3 ways. So that is a general, quick, airplane 3,000-foot view of everything that we've done in pre-calculus. If anything here is particularly like, please don't put those on the test, you can let me know that. You can send me an email and say, Mr. Freitag, please don't put anything about logs on the test, or please don't put anything about whatever. I will do my best maybe to help you feel a little better about that, or I might oblige the request. So describing functions, stuff about limits, trig equations and formulas, chapters 4 and 6, graphing of sine and cosine and other things with trigonometry, exponentials and logs, area under a curve with our summation notation and our rectangles, trapezoids, radians as angles in the unit circle, and then we started, as I said, with parent functions and transformations. Okay, so If any of this stuff, like I said, is uncomfortable for you, let me know. I'd be happy to help. But I would like to know that, I suppose. Otherwise, that's all I have for you, and we'll finish strong, and I'll talk to you soon.